Hello everyone, welcome back to Educquiz. Today we are going to do is start a new chapter, new topic, which is matrices. So here is our table of content. Here is what we will do during all of the course. All we do is firstly a brief introduction to matrices, secondly the types of matrices. Then we do the basic operation of matrices, which are application of matrices. Then we will talk about some special properties of matrices. Then we'll learn how to find the determinant of any type of matrix. Then we'll learn how to find the transpose of a matrix. Then we'll learn how to find the cofactor of a matrix, which these two combined, which is the transpose and the cofactor of the matrix, is the same like the adjugate of a matrix. So the adjugate is the cofactor of the transpose of a matrix. So we'll learn also how to find the inverse of a matrix. We'll learn how to use matrices to solve a set of inequality of a set of functions. So for us to solve simultaneous equations, first using the inverse. So we use the inverse to solve simultaneous equations. Then we'll use Cramer's rule to solve simultaneous equations. So without wasting much time, let's dive into a brief introduction to matrices. So what is a matrix? A matrix is just a square or a rectangular representation of quantities. It could be numbers, it could be letters. So an example of a matrix is this is a matrix. So if a matrix has n columns, if it has m rows and n columns, I hope this is how it's written. Yeah. Then it is an m by n. It is written like this, but it is said m by n matrix, where m is the number of rows and n is the number of columns. So to remember that it is in the order m by n, just know that the x-axis is the number of rows and the y-axis is the number of columns. You always start with x. You always say x, y, n. So x-axis, you have horizontal rows. The rows are horizontal. In this case here, you have 2 rows. And the columns are vertical. We have 1, 2, 3 columns. In this case, there are 3 columns. So it is a 2 by 3 matrix in this case. Matrix could also be of this form. This is a square matrix. So we are going to go further to the types of matrices. So for the type of matrices, we'll start with a row matrix. And number 2, Roman 1 row matrix. So what is a row matrix? A row matrix is actually a matrix that has just one row. For instance, you have 2, 5, 7. There's no bracket there, sorry. 2 by 7. Yeah, just one row. This is a 1 by 3 matrix because there are 3 columns. You will have 1, 2, 3, 4. I don't know why I like putting brackets, commas, but there's no comma there. So this is a 1 by 4 matrix. This is also a row matrix. So another type of matrix is column matrix. So what do you think is a column matrix this time? I think you guessed well. It is a matrix using just columns, just one column. So here's a matrix like this: 1, 2, 3, 4. It has, you can have many rows. This is 1, 2, 3, 4 rows. This is 4 by 1 column. It has just one column. It is called a column matrix. So the next type of metric is square matrix. I think you also can guess what the square matrix is. So a square matrix is a matrix which has the same number of rows and columns. So the number of columns is equal to the number of rows. Here you can see that there are 2 rows and 2 columns. This is a 2 by 2 matrix. So any 2 by 2, 3 by 3, 4 by 4 matrix, this is square matrix. So we also have a 0 or a null matrix. So as Roman 4 here, we have 0 or null matrix. This is a matrix where all of the entries are 0. So every matrix, all the entries are 0. It must not be a square. I recopied the same thing all them. Okay. This is also a null matrix. So you also have a diagonal matrix. What is diagonal matrix? Diagonal matrix. So what is a diagonal matrix? I think you guessed well. Diagonal matrix is a matrix whose diagonal are not 0. So you have 1, 0, 0, 2. This is diagonal matrix. All of the other entries are 0 except the diagonal. That is a diagonal matrix. So the diagonal matrix it is a matrix where all of the entries are 0 except the diagonal. The diagonal is it's a diagonal line. The diagonal coming starting from the left, not from the right. So you can have this matrix. What is the order of this matrix? I think you guessed right. This is a 2 by 2. Well, this is a square. What question am I even asking? Well, we can notice here that diagonal matrices can only happen in square matrices. Yeah. Because it's only with a square that you actually have a diagonal. Let's say something. If you have 1, 0, 0, 1, 3, 4. Yeah, we can't say it's a diagonal matrix. Because you don't know. If you say this is the diagonal, then there are still some under. If there was another one here, you could say, yeah, this line is a diagonal. But since this is just 2, you cannot say when there are 3 rows, there cannot be just 2 diagonals. So we conclude that the diagonals appear just on square matrices. So that was about diagonal matrices. So the next is a scalar matrix, an identity matrix. What is an identity matrix? An identity matrix is a matrix where here you can see that this is the diagonal matrix. An identity matrix is actually a diagonal matrix where all of the diagonal values are 1. So you have 1, 1, 1. This you say is an identity matrix. Yeah. So that is it for the major types of matrices. So next we are going to look at the basic operations on matrices. We're going to look at basic operations on matrices. So we are on number 3 looking at basic operations on matrices. What are the basic operations in matrices? We have addition and subtraction on matrices. So addition and subtraction on matrices is quite easy. You have 2, 1, 4, 2, maybe. Yeah. For addition, you're going to have maybe 3, 4, 5, 6. This is square matrix adding a square matrix. Note that the order of the matrices which you add must be the same. You cannot add a 2 by 2 matrix to a 2 by 3 matrix. It cannot be added. So you add a 2 by 2 to a 2 by 2. Add a 3 by 3 to a 3 by 3. Add a 2 by 1 to a 2 by 1. The order must be the same. So here, what will be the answer? I think you know it. Plus 4. And it is the same for subtraction of matrices. Just as easy as that. 2 minus 3 minus 1. 1 minus 4 minus 5. Minus 1. 3. Sorry. 4 minus 5. Minus 1. And 2 minus 6. Minus 4. You just subtract just like you subtract your natural numbers. That's just it. So that is about addition or subtraction of matrices. I think it is well understood. That was A on addition or subtraction of matrices. B. For the B part, we have scalar multiplication. Scalar multiplication means you multiply a whole matrix by a scalar. A scalar is a number, a positive number, a constant. So you can have a matrix like, let's say M. N will be our matrix denoted by 1, 2, 3, 4, 5, 6, 7, 8, 9. We have our matrix M. When we say now scalar multiplication, they can ask you in a question. A question can say find 3M. You have your M as a matrix, they ask you find 3M. 3 here is actually the scalar or a constant which you are multiplying. So how do you multiply? How do you find 3M? I think you guessed right. You just do 3 into 1, 2, 3, 4, 5, 6, 7, 8, 9. Means you're multiplying everything by 3. When you multiply everything by 3, you are going to have it equal to 3 times 1, 3, 6, 9, 12, 15, 18, 21, 24, 27. That is just your scalar multiplication, like that. So, otherwise, it is the same thing if you are multiplying by 4, if you are multiplying by 5, as easy as that. So that is it for scalar multiplication. Let's do matrix multiplication. Alright, going to see where C is matrix multiplication. We are going to see how to multiply through matrices. Okay, there's one rule to know here. When multiplying two matrices, you multiply a matrix M by N, an M by N matrix. Do this times an N by A matrix, where M, N and A are elements of natural numbers. With a star meaning it excludes 0. Natural numbers are all of the numbers starting from 1, 2, 3, 4. Natural numbers are all integers excluding 0. So, or I could just put integers. Well, negative numbers are also integers. So natural numbers, yeah. numbers starting from 1, 2, 3, 4. The star here means it excludes 0. So you can have, for you to be able to multiply a matrix, the number of column of the first matrix must be equal to the number of row of the second matrix. Let's take an example. We'll have 1, 2, 3, 4, 5, 6, 7, 8, 9. I'm just taking some random things. I'll better take some small values, even though I will have to multiply big values. Here you can see that we have 1, 2, 3 row and 1, 2, 3 column. Well, I want to take something that is not square. In case you have a 2 by 3, 2 by 3, you can have 1, 2, 3, 4, 5, 6. Here is 2 by, here is 2. Oh, this is 3 by 2 instead. Okay. 5, 6 instead here. We have 5 and 6 instead here. This is 2 rows and 3 columns. This is 2 by 3 matrix. In case you have this matrix, you cannot multiply it by another 2 by 3 matrix instead. For instance, you'll be like, how come something cannot multiply itself? Immediately, it is possible. Something cannot multiply itself if they are of the same exact order. This cannot be multiplied because the number of columns on the first matrix is not equal to the number of rows. How many columns are here? 1, 2, 3 columns. How many rows are here? 1, 2 rows. If there were 3 rows, they would have been able to multiply. Let's see why you cannot multiply. When you multiply, you do this times this. You have your answer as 1. Then you do this times the second one down. It is rows times columns. So you do 2 times 3, you have 6. Then you have to do 5 times something. When you do 5 times, what else is here that you can multiply? You cannot multiply. So you see, you cannot do multiply. So when you look at matrices, when they ask you to multiply 2 matrices, sometimes they put a trap there. They tell you multiply these 2 matrices, knowing that the number of columns of the first matrix is not equal to the number of rows of the second matrix. In that case, you should write there, since the number of columns of the first matrix is not the same like the number of rows of the second matrix, this operation cannot be done. These 2 matrices cannot be multiplied. So now that we know the rule for multiplication, let's find some matrices to multiply. Let's say 1, 2, 5, 3, 4, 0. 1, 2, 1. I'm trying to run away from big numbers. Here you can see you have 1, 2 rows, 3 columns. So if you want to multiply it, have something that has 3 columns. 3, 0, 1. 2, 5, 2. 4, 1, 0. 4, 4, 6. Let's have this. 2, 1, 6 or 3 here. Let me multiply some number because I don't want big numbers. Anyways, so we can see here that the number of rows, what is the number of rows? 1, 2. The number of columns, 1, 2, 3. So it is a 2 by 3. Let me write it on top. 2 by 3 matrix. What is the number of rows here? 1, 2, 3 rows. Number of columns, 1, 2, 3, 4. 3 by 4 column, 3 by 4 matrix. You see that these two last are the same. The number of columns here is equal to the number of rows here. So whether this thing is different from this thing, they can multiply. You are seeing that these are completely different. This is smaller, this is bigger, but they can multiply and give one answer. And you look at the form of the answer. It will depend on. Let's solve and see. So when I solve, I multiply the rows by the column, the rows of the first matrix by the column of the second matrix. So I can multiply like this. 1 times 3. I'll have, let's say, m is equal to this, n is equal to this. M times n will be equal to 1 times 3 is 3. 1 times 3 is 3, we multiplied. We go to the second times the second down. The second horizontal row, vertical column, the second column up, the second column on the first row, and the second row, the first column on the second row. So we do this times this, then this times this, then this times this. So 2 times 0 is 0. 1 times 3 is 3. 2 times 0 is 0. 1 times 1 is 1. No, what am I doing? Actually, you add them. So it is 1 times 3, 3. 2 times 0 plus 0. 1 times 1 plus 1. Like that. So you do have your value. You go to the next. 1 times 2. 2. 2 times 3 plus 6. 1 times 2 plus 2. Then you go to the next. You have 1 times 4. 4 plus 2 times 1, 2 plus 1 times 0, 0. Then you go to the next. 1 times 2. This 1 times this 2. 2 plus 2 times 1, 3. How do I know where to position these things? This is the first row. So it should be positioned on the first row. This one here are the first 4 columns. You multiply this first row by the first 4 columns. So they are positioned on the first column, second column, third column, fourth column. The first 4 columns. So it depends on this position. So now when you are done, you come and multiply here. 3 times 3 is 9. 9 plus 4 times 0 is 0. 0 times 1 is 1. I'm done with this. The second row and the first column. Now you see it is on the second row and on the first column. This position is the same where it is. You multiply the second row and first column, you put it on the second row and the first column. I think it is second under on the first column, you put on the first column. Now you go second row, second column, do the same there. You have 3 times 2, 6, plus 4 times 3, 12, plus 0 times 2, 0. Are you seeing that you have a second row, second column? It comes on the second row actually and on the second column. It's just the same. So we do same here. We have 3 times 4, 12, plus 4 times 1, 4, plus 0 times anything, 0. Or it just means 0 for instance. Second row, third column, this second row, this third column. You do same for the last. 3 times 2, 6, plus 4 times 1, 4 plus 0. Yeah, that's what we are going to do. So let's just finalize and have our answer. 3 plus 0 plus 1, 4, 2 plus 6 plus 2, 10, 4 plus 2, 6, 2 plus 2, 4 plus 3, 7, 9 plus 1, 10, 6 plus 12, 18, 12 plus 4, 16, 6 plus 4, 10. So this is our final answer. What do we notice from this final answer? We notice that the This matrix was a 2 by 3 matrix. That is the order. This matrix was a 3 by 4 matrix. The order of the answer is a 2 by 4 matrix, which is this 2 by this 4. This 2 by this 4. So you should make sure that when you multiply matrices which have these two same answers, the result should be this. That means the order of the result must be a 2 by 4. If here was 3 and 5, the order of the result must be a 3 by 5 matrix always. So when you solve, you check the result. The first thing that will make you to know that it's correct is this. Before checking your answers. So that's how you do multiplication of matrices. So the things that is written is, when you multiply matrices, you check for the number of columns of the first matrix. Columns are vertical. Check the number of vertical columns. And you also check the number of rows on the second matrix. Rows are horizontal. Check the number of rows. Here, so there are 1, 2, 3 columns. Here there are 3 rows. So they can multiply. If they are different, then they cannot multiply. But they will rarely give you cases where they are different. But always check. They can give you a case where they are different. Before multiplying, check the column and the row. Then make sure when you multiply, the order of your final answer to be the first row and the last column. Yeah, that is the order. That is the order of the answer. And make sure when you are multiplying, multiply a whole row by a row column, and you put it on the first row and the first column. If it is the whole first row times the whole first column, must you add it and put it here. If it is the whole first row and the whole second column, put it on the first row and second column here. They all have to fit here. So you do same for all of them. Right. So we are done with multiplication of matrices. Matrices. Well, what do we do next? We are going to do special properties. So, for the special properties of matrices, we know that, let's assume we have the matrix A and the matrix B. Special properties say that if you do A plus B, it is the same like if you do B plus A. That is the first property. That is the commutativity law. So this thing means it is commutative. That's the first property. Second property, if times B actually A into B plus C is equal to A, B plus A, C. This is the distributive property. So if you have a matrix A into B plus C, you have AB plus AC, that is the distributive property. Now, that property, if you have A into BC, it is the same like you take these two, AB, and multiply by C alone. This is the associative properties. Associative property, this is actually Roman 3. Okay. For the other property, A times I, where I is the identity matrix. Remember what identity matrix was? 1 0 0 0 0 0, 1, 0 here, 0, 0, 1. 3 by 3 identity matrix, you have this. 2 by 2 identity matrix, you have this. It's a matrix where the diagonal entries are all 1 and all of the rest is 0. So A times I is the same like I times A. Remember, in matrices, A times B is not the same like B times A, except if A is an identity. If I is the identity there, if you replace this B by I, then you can work. And then this is the same like A. Review A times I is the same like I times A, and it is still the same like A. Because if you multiply a matrix by 1, 1, 1, then 0, 0, you still give you the same matrix. So that's why you call it identity matrix. It just reflects, it's just a kind of a mirror. But you use that in solving when we reach here, using the inverse method, we see the importance of the identity matrix, even though it looks like it's just repeating it. So the fifth law we have, when we multiply A by 0, we have 0. That's the fifth law, just as simple as that. When you multiply anything by 0, you have 0. Same as if you multiply a matrix by 0, you have 0. And the sixth and last law is, as I said, A times B is not equal to B times A. Some people think like as 2 and times 3 is the same like 3 times 2, it works with matrices. They will say go and do BA. You go and take A first because it suits you. Go and put A first, then you go and put B, then you multiply. The answer will be wrong. It is not the same like you put B first. You have the answer. It will be different than you put A first, then you put B. So okay. So now we are at 5. We are entering into business actually. Finding the determinant of matrix. Don't mind me. The determinant of a matrix is not a difficult thing. Okay, so we are number 5. It is determinant of a matrix. So we are diving into a very crucial part of matrices, finding the determinant. Almost everything that you do in matrices will deal with determinant. So you have to master how to find the determinant of a matrix. So how do you find the determinant of a matrix? Let's assume the matrix M is a 2 by 2 matrix with entries A, B, C, D, where A, B, C, and D are integers or real numbers, any number. The determinant of a matrix is denoted by N determinant, like this modulo sign. And it is, how do you find it? You find it by doing AD minus BC. So the determinant is this time this minus B, this time this. That's how you find the determinant of a 2 by 2 matrix. For instance, let's take an example. The matrix N is 1, 2, 3, 4. The determinant of N is going to be 1 times 4 minus 3 times 2 is equal to be, is going to be 4. 1 times 4 is 4 minus 2 times 2 is 6. So the determinant is going to be minus 2. So yeah, that's how you find the determinant of a 2 by 2 matrix. Now, for a 3 by 3 matrix, let's assume M is a 3 by 3 matrix A, B, C, D, E, F, G, H, I. So here, so to find the determinant of M will be represented as m without magnitude. You do a, you cancel here. When you write the first letter here, do a, you cancel here, and you write what is left. You cancel here and you cancel here. So you don't write this. What is left is E, F, H, I. So you find the determinant of E, F, H, and I. That's what you do. Plus, this is actually going to be minus B, and you find here. You cancel here and here. You'll be left with D, F, J, G, and I. D, F, G, and I. Yeah. So, and then you do same with C. You cancel the row and the column. So you have plus C. This sign is always plus, minus, and plus. To have the sign actually, well, I'll show you how to have the sign when we'll be doing cofactors. Cofactors, all the sign actually you are doing -1 to I plus J, where I is the row, the position, and J is the position of the column. So yeah, so how the sign here, if it is positive or negative, you use a formula. If you use a formula, this A is row 1 and column 1. So the sign here will be -1, row 1 and column 1. 1 plus 1 is 2. So it is equal to -1 to the power 2, which is equal to 1. 1 means positive. So the sign here, what is here is 1. So have the sign that is here, you look at here, it will be -1 into I plus J, which is equal to -1 into I. The number of row is first row. Number of column is 1, 2. Second column, we have 1 plus 2. Is equal to -1 to the power 3, which is equal to -1. -1 to the power 2 is -1. Actually, you can punch your calculator. That is why we have a negative here. So our next is going to be -1 to the power 4, which is equal to 1. And that's always how it increments. Here you are going to have 5, 6, 7. So this is plus, minus, plus, minus, plus, minus, plus, minus, plus. Yeah. So that is how you find the determinant of a 3 by 3 matrix. So let's take an actual example. 1 minus 2, 0. 1 minus 2, 0. 3, 1, 5. 1, 2, 3. So for instance, we have a matrix like this. Okay, so if you are asked to find the determinant of that matrix, what do? We take 1, put 1 outside, the sign is plus. 1, you cancel this, you'll be left with this. You write here 1, 5, 2, 3. Then minus, we have minus 2. This minus here is not included in our minus that is here. The sign is normally minus. So you put your minus, then you look at what is here. Oh, I have a minus 2, so you write your minus 2. Don't say because there's minus here, you are writing 1 minus. Don't. You have to write minus minus. Because here, if it was plus, it would have been 1 minus without it here. It would have been minus 2. Since it is minus, you put your minus minus 2. So when minus crosses minus, it becomes plus. So if you have this, it becomes 2. Same like if you have something, if it is 1 minus minus 2 without the bracket, it becomes plus. the answer. So yeah, I have it like this. When I cancel here and here, I'll be left with this. So I have 3, 5, 1, 3. I put it in this magnitude form to show that I have to find its magnitude. So I have to show that you should show that what multiplies 1 is actually the magnitude of this. 1 multiply this minus 2 is actually the magnitude of this. So I do the same for 0. 0 times anything is 0. Yeah. So I can, if I cancel here and I cancel here, I'll have 0 times. It's actually plus. So this is plus, minus, plus. The first here is plus, the first position. The second sign is minus. The third sign is plus. When we see cofactor, we'll see that we are going to do that for everything. The fourth sign will be minus, plus, minus, plus, minus, plus. So it just goes like that. So when you do plus for 1, you have negative 2, you put your minus. Then on the third one, you put your plus. But since it is 0, anything, multiply anything, it will be 0. But if it was not 0, if it was 1, we have done this. And then it would have been 3, 1, 1, 2. Good. So from here, it's equal to 1 into 1 times 3 minus 2 times 5. Minus 2 is the same like plus 2 into 3 times 3 minus 1 times 5. Now plus 0 times anything is 0. So it is equal to 1 into 3 times 1 is 3 minus 2 times 5 is 10. Plus 2 into 3 times 3 is 9 minus 5 times 1 is 5. So it is equal to 3 minus 10 is minus 7. So minus 7 plus 8 is equal to 1. It implies the determinant of m is 1. Determinant. We are going to take another example, finding the determinant. So let's consider an example 3, 2, 1. 1, 3, 2, 4, 1, 3. Okay, let's consider the second example. To find the determinant of m, you write the m in the magnitude there. Determinant of n is equal to, as we said, you take 3, write your 3. It is positive because it is the first value, so it is plus 3, positive 3. Then it is, you put your determinant, you cancel here, what will be left is this. You have 3, 2, 1, 3. Now, the second one is minus. When I put my minus, then I can look at the sign. What is the sign here? Oh, it's plus 2. So I'm at minus 2. Then when I cancel here and here, I'll be left with this, because I cancel the row, the first row, and the second column. So I'll be left with this. These are the things that were not cancelled. So that's what I'm left with. 1, 2, 4, 3. Then, since I've put plus minus, then I'm to put plus again. Plus, I have 1. If this was minus 1, this was minus 1 here, I would have put minus 1 here. Since it is plus, I put plus. If this was minus 2, I would have put minus 2 into bracket as I did in the previous example. Yeah, so I put my 1. This was not minus. Put my 1, then I cancel the row and the column on 1. I'll be left with 1, 3, 4, 1. Put my plus here. 1, 3, 4, 1. Yeah, when I do that, I'm almost done. So that will be equal to 3 into 3 times 3. Put your bracket. Because you're solving already, you put your bracket. 3 times 3, I'll put 9 minus 2 times 1, 2. Minus 2 into 1 times 3, 3 minus 4 times 2 times 4, 8. plus 1 into 1 times 1, 1 minus 4 times 3, 12. So that will be equals to 3 times 9 minus 2, 7. 3 times 7, 21 minus 3 minus 8 minus 5. Minus 5 times minus 2, 10. So it's plus 10. Minus 5 times minus 2 is plus 10. So I write the plus 10 here. Now, plus 1 into 1 minus 12 is minus 11. So I do minus 11. So if you solve this normally, you have your answer as 20. So here 20 is a determinant. I think it is well explained. So we can go to the next, finding the transpose of the matrix. The next is finding the transpose. Before reaching the transpose of the matrix, I want to give you one exercise on determinant of a 3 by 3 matrix. So, imagine you are given a matrix M. It's noted as 1, 2, 3. 4, 5, 6, 7, 8, 9. If I do this, find the determinant of this. Check. Check that your answer is negative 41. So, what are we going to do next? We are going to learn how to find the transpose of a matrix. So, transpose of a matrix. Let's imagine a matrix M being 1, 2, 3, 3, 2, 4, 4, 3, 2. Let's imagine this being the matrix M. The transpose of the matrix is denoted as M with the T up. That is a transpose of the matrix. Okay, so transpose of the matrix. How do we find the transpose of a matrix? Actually, what we do is just like the way we were doing for determinant. We are going to take this one, take one, you cancel like this. And we do this time is this. What am I doing? That's for cofactor. Okay, to find the transpose of a matrix, what do you do? Columns, and all of the columns become the rows. So if you have a 3 by 3, if you have a 3 by 3 matrix like that, okay, let's start with the 2 by 2 matrix first. Let's imagine we have a 2 by 2 matrix as 1, 2, 3, 4. To find the transpose of the matrix, we are going to switch. This diagonal is going to remain the same. These things are going to switch. Maybe 1 and 4, we keep it, then we switch this. We're going to have 2 and 3. How will the transpose N T denoted by N with a small t on top? If you have a 3 by 3 matrix like this, how do we find the transpose? It is denoted as N with a small t on top. This row will become the first column. How do you do it? You have 1, 2, 1, 2, 3. Because it was 1, 2, 3, write it down like this. Then the second row becomes the second column. 3, 2, 4 becomes 3, 2, 4. Same for the last 4, 3, 2, 4, 3, 2. If you have difficulties in remembering the order, what I used to do is, when they ask me to find the transpose, M transpose, what I do is I keep the diagonal the same. 1, 2, 2. I keep it first the same. Then I switch this and this line, and I switch this line, and I switch this line. Knowing that the diagonal is the same, I switch this line, I switch this 3 and 2. I switch these 2 because the diagonal is the same, I switch these 2. I put 3 and I put 4 here. 4, 3. Now I switch these 2. I put 3 and I put 4 here. 3, 4. That's the same. Well, but I think putting this here, putting this here, putting this here, it's even simpler. So you can use any of the methods if you find confused in one of them. So that is how you find the transpose of. Okay. So we are now going to, oh, that was 6. We are now going to 7. 7 is the cofactor of a matrix. How do we find the cofactor of a matrix? Cofactor of a matrix. I write it because it's a little bit longer. So let's have a matrix like 1 minus 2, 0. Zero, 5, 3, 1, 2, 3. Okay, let's find the cofactor of this matrix. Let's imagine we have a matrix M equal to this. If you are to find the cofactor of the matrix, which is M cofactor of the matrix, it is another matrix which you call the co-matrix or the cofactor matrix. You can call it the co-matrix or the cofactor matrix. So how do I find the cofactor? The way we did for the determinants, you take this one, you put it like this. What is the sign here? The sign here is plus, minus, plus, then minus, plus, minus, then plus, minus, plus. So the first sign is plus. Is plus, minus, plus, minus, plus, minus, plus, minus, plus. If you doubt, you can use this formula. Minus 1 to the power I plus j, where I is the position of the row and j is the position of the column. Second row and second column. Second row and second column. Plus. Let's take any random one. This one. This is the third row and second column. So this is the third row and second column. That is minus 1 to the power 5, which is minus 1. You know the answer because of the power. If the power is odd, then the answer is negative 1. If the power is even, then the answer is 1. In this case, the power is odd, so it's negative 1. That's why you have a negative sign for this one. You find the cofactor of each number, of each number, yes. So you have to find the cofactor of 1. You'll be 1. The cofactor of 1. You'll be, you cancel here, you cancel here. You have 1, 5, 1, 3. That is plus. Then the cofactor of 2. That's cofactor of 1. Cofactor of minus 2, for instance. You cancel here and you cancel here. You have 3, 5, 1, 3. The sign is minus, so it's minus 3, 5, 1, 3. You do same for this. You find the cofactor of minus 2. You do this. You have minus here. You have 3, 5, 1, and 3. Then you do the cofactor of 0. It will be equals to, the sign is plus. That the sign as plus. Then you have 3, 1, 1, 1. 3, 1, 1, 1. Like this. So you find all of these cofactors and you put it on. When you find the cofactor of 1, you put it on position 1. When you find the cofactor of 2, you put it at position 2. When you find the cofactor of 3, you put it at position 3. So let's find these first 3 cofactors. So here the determinant is what? 1 times 3 is 3 minus 1 times 5. So let me start writing. Factor of m is 1 times 3 is 3 minus 1 times 5 is minus 2. Here is minus 3 times 3, 9 minus 5 times 1, 5. 9 minus 5 is 4. But this minus that is here is minus 4. So 3 times 1, 3 minus 1 times 1, 1. 3 minus 1 is 2. That's how you write it. Do same here. You cancel here, you cancel here. You'll be left with this, 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 this. So cofactor of 3. Because when you cancel here and you cancel here, you'll be left with 2, 0, 1, and 3. 2, 0, 1, 3. What is the sign here? The sign is minus. So 2 times 3 is 6. 6 minus 0 is 6. Since the sign is negative, you put your negative 6 here. Then you find the cofactor of 1. 1 is plus. And because of the determinant of, you cancel here and cancel here. You cancel this middle and this middle on the 1. We left with 1, 0, 1, 3. 1, 0, 1, 3. So 1 times 3 is 3. 1 times 0 is 0. So we just 3. You do same for the cofactor of 5. Cofactor of 5, the sign is negative. Put your determinant, you cancel here and here. You have 1 minus 2, 1, 1. Cofactor of 5, you have 1 minus 2, 1, 1. Yeah. 1 minus 2, 1, 1. That's what you're going to have. So you do 1 times 1 is 1 minus 1 times minus 2. You have 1 times 1 minus 1 times minus 2 is equal to 1 minus 2 plus 2 actually. Because this minus will multiply this minus, I have 1 plus 2, which is 3. Since there is already a minus here, it will be minus 3. That is what it is going to be. So you do same for this last one. You cancel here and you cancel here. What will you be left with? Minus 2, 0, 1, and 5. So the cofactor of cancel here and you cancel here for this one. You have minus 2, 0, 1, and 5. Minus 2, 0, 1, 5. Here it is plus, the sign here is plus. So when you find the determinant here, you do minus 2 times 5 is minus 10. Minus 10 minus 0 is still minus 10. Sign is plus, so write your minus 10. You do it for this. You cancel here, this middle, and you cancel here. You'll be left with 1, 0, 3. Cof of 1, 1, 0, 3, 5. It will be equal to 1 times 5 is 5. 3 times 0 is 0. This sign here is minus. So you put your minus here. 1 times 5 is 5. 3 times 0 is 0. 5 minus 0 is 0. Since the 5 is here, it's minus 5 the answer. You put your minus 5 here. Then the last one. You cancel here and here. You have 1 minus 2, 3, 1. 1 minus 2, 3, 1. So 1 times 1 is 1 minus 1 times 1 minus 3 times minus 2. 1 times 1 is 1 minus 3 times minus 2 is minus 6. So 1 minus minus 6 is 1 plus 6. That is 7. You have 7 there. And you're done. So that is how we find the cofactor of the matrix M. So you actually find the cofactor at any place. It's actually tedious, but it's worth the time because I'm going to give you much marks for that. And depending on the teacher, it must not be much marks. So yeah, I've put them in braces, then this outside. So not do a different one called adjugate. What is the adjugate? The adjugate is just the cofactor transpose. Like when you find the cofactor like this, if they ask you to find the adjugate of this M, you first find the cofactor like this, then you find the transpose. The transpose is quite easy. Cof M transpose is equal to adjugate of M is equal to find the transpose, the rows become columns. So you put your negative 2, negative 6, negative 10. This, you put it here. Negative 2, negative 6, negative 10, negative 10. Then this is on the second. Minus 4, 3. Minus 4, 3. Minus 5. Then the last one. This is on the last one down. 2, minus 3, 7. So this is the adjugate. Yeah, this is actually the adjugate of the function. The adjugate is just the transpose of the cofactor. You find the cofactor like this, and then you make its transpose. This is the adjugate. So when we do that, we can then find the inverse of a matrix. What is the formula for inverse of a matrix? I don't really want to wipe this because we're going to use it. What was that matrix again? Okay. So 1 minus 2, 0, 3, 1, 5, 1, 2, 3. If this is my matrix M, it asks me to find the inverse if this is my matrix M, they ask me to find the inverse of the matrix M. How do I find the inverse of the matrix? M inverse, I put it with the power minus 1 like this, is equals to 1 all over the determinant of M times the cofactor transpose or the adjugate. As we did. 1 all over the determinant times the adjugate. Transpose, or you can see times ADG like this. So let's just do the example with the values that we had already. We have the cofactor transpose or the adjugate of this function at like this. So what is actually the determinant? We definitely need the determinant to find the inverse. What is the determinant of this function, of this matrix? So the determinant is equals to, I take 1, multiply 1 times 3, well, 1, 5, 2, 3, then minus 2, I can just put plus 2, plus 2, I cancel this, I will left with this. 3, 5, 1, 3. Then 0, I can ignore 0 because anything multiplied by 0 is 0. So I'll just leave it like that. So what will be the determinant? 1 times 3 is 3. 3 minus 2 times 5 is 10. 3 minus 10 is minus 7. 3 times 3 is 9. 9 minus 1 times 5 is 5. 9 minus 5 is 4. So minus 2 times 4. That will give minus 7 plus 8. This is minus 4. Minus 7 plus 8. That will be equal to 1. I mean, we calculated it before and it was 1. So, since we have the determinant of the matrix M and we have the adjoint or the cofactor transpose of the matrix M, then we can easily find the inverse of the matrix. So to find the inverse, we have M inverse will be equals to, from the formula, it is 1 over the determinant times the adjunct. 1 all over 1 times all of this. Minus 2, minus 6, minus 10, minus 4, 3, minus 5, 2, minus 3, 7. So 1 over 1 times that is just it. So in this case, this will just be the inverse. But if you had something like 2 here, it would have been 1 over 2. So you would have divided all of these numbers here by 2. You would have done this by this on 2, 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 this on 2. Depending on the determinant that you have.